We learned that the Arduino will convert the 0 to 5 analog signal to a digital number between 0 to 133. However, sometimes it is not that case, meaning we will get different subset range between those maximum value, between 0 to 133. We will get something less than that. The main reason for this is that every sensor is a little bit different and will provide a varying range of voltage levels depending on what they are actually sensing. For example, imagine a sensor that generates value instead of 0 to 5, it will generate between 1 volt to 3.5 volt. So in that case, 1 volt as an analog input should be represented by 0 digital value. So in order to better understand the range of value that a particular sensor is providing, we will use the serial monitoring options to help us visualize the value reported by the Arduino. And based on that, we will be able to normalize the data. Serial communication is used by two digital devices to talk to each other. And in our case, the USB connection is the serial communication protocol between our Arduino and our computer. We already used it to upload our source code to the Arduino board. Now we can use the serial monitor included in the Arduino programming environment to actually see the values that the Arduino is reading from such external sensor. In our case, before using the potentiometer to control another piece of hardware in our project, we will print out the potentiometer range, even if we know the expected result from a potentiometer, because it's relevant to an analog sensor that we may use in the future. So let's move on and start to learn how to set it up and use it. Before we can use the serial communication working with the Arduino board, we need to first establish the communication speed between the two devices using the serial.begin function, and we will do it as part of the setup function using one line of code, what you see right now, serial.begin and some number inside. The number is actually a communication speed parameter measured in baud rate, where 9600 baud is a common value that we should use. For printing information in any location in our code, we have two functions, serial.print and serial.println. They are almost the same, except that the second one will print the information and will start a new line. Now, in our case, we would like to print the current value we got from the two variable resistor. And let's review the relevant code and the actual result in our project.